listening to this continuing education seminar from Environment and Disaster Management. This is our 9th seminar in the series. And before we get started with the topic of today, which is early warning systems for fishing communities, I will just go full of slides related to our team, the Environment and Disaster Management team at WWF US. For those who don't know us or haven't joined one of these seminars before. And so our team basically works to integrate environmental considerations into disaster risk reduction, recovery, and reconstruction. And we have 3 main areas of work. So we have here the first one, which is related to green recovery and risk reduction. And there's a toolkit that we have for that, which is called the GERT in short. And then we have another area of work related to flood management. We have a guide called the Flood Green Guide, and basically which promotes natural and nature-based flood management. And then we also have all related infrastructure work. For example, that's the work where we analyze the environmental impacts of building materials. And so I am a senior program officer with the Environment and Disaster Management team at WWF US. And so we have been doing these seminar series for over a year now. And they have been open to the public since, I guess, September. So we're happy that you have joined us for this one as well. And we are trying to do these bi-monthly. We always want to encourage people to volunteer as speakers. If you would like to share with community practice, and also you can recommend other people as speakers. Please also send us your topics of interest if there's a specific topic you would like to see us include in this series. And for today, so we have a meeting setting, so it's not a webinar. So during the Q&A section, you can raise your hand if you want to speak up and ask a question directly, or you can also enter them in the chat. But please just make sure your microphone is muted while others are presenting. And before I pass it on to Mr. Toki, who we are very lucky to have today, because he will talk to us about this forecast early warning system for fishing communities, I will actually pass it on to Lilia, our colleague from WWF Madagascar, who is going to talk to us a little bit about how they're working with aquatic services, who is implementing these early warning systems that Mr. Toki invented. And so Lilia is going to talk to us also a little bit more about how that collaboration has started. So I'll pass it over to Lilia. Thank you, Lilia.
Thank you, Rose. And hi, everyone. Happy New Year for those that we've met the first for this year. So I would like to share short presentation in regards WWF Madagascar actions with regard DRR. So may I share a short presentation, please?
You should be able to.
Yeah. So I'm Liliara Sufmanana, and I'm coordinating the mangrove program within WWF Madagascar office. So here in Madagascar, WWF is intervening in 4 priority landscapes, 2 priority landscapes in the north, one which is forest and one is a marine. This is the 3rd priority seascape that we intervene, and the 4th is in the south of Madagascar, which is the Mafali seascape. So this is just the intervention for WWF Madagascar as a whole, and our goal is about conservation of the biodiversity and the ecosystem, marine and terrestrial, and also the improvement of the local communities' livelihoods and living conditions in those priority land and seascapes. With regard DRR activities, we did not have so much experiences so far, but we have this project, Mangrove for Community and Climate, which is funded by the Bezos Earth Fund and will be implemented from 2021 until 2025. So this, I could say that this is the first project that we have clearly defined goals, outcomes and activities with regard to TRR aspects. The scope of the project is we are mainly work in the two priority landscape among the four that we are intervening now. So in this part in the north, we called it the Diana seascape, and here in the west part, which is the Manambulu-Tsirbiana seascape. So we are planning to undertake some DRR activity in collaboration with the aquatic services, which is represented by Tuki here. And with regard to this activity, the challenge in those areas includes climate change, mainly the cyclone, the rainfall pattern, which is like changing, and the local communities there are experiencing strong winds, sea level rise and flooding. And with regard to this climate change aspect that we are have proposed this DRR activities, and also in order to increase the resilience of the local community, but also the resilience of the mangrove in those areas. So within this building community resilience, we plan to design and to implement disaster risk and extreme event management mechanism with the local community, with the local stakeholders here in Madagascar at local and at national level. This, as I said, this is to improve the local community's resilience to the climate risk. The collaboration with the aquatic service team is now in the starting phase, as we are still in the contracting phase now, but there is already a field visit to see the context at the landscape level, and also to consult the local community for their interests to implement this early warning system, the MICTAU forecasts, to help them to cope with the wind and to improve their activities, planning, and livelihoods faced to these strong winds in the region. So this is why we are developing this partnership with the aquatic service who will present the system today. So thank you very much.
Thank you. Thank you so much, Lilia. So I will pass it on to Mr. Toki Sylvester right now, who we are very lucky to have with us today. So Mr. Toki has developed this early warning system for fishing communities, and he is also a part of representing aquatic services today. He is an oceanographer for training, but he has developed this really impactful early warning system that we will hear about. So Mr. Toki, I will present your slides. And thank you again so much for joining us.
Thank you, Luz, and hi everyone. good afternoon, according to where you are, because you are spread all over the world in this seminar today. Luz has presented earlier that today we are going to talk about the wind phenomenon related to fisher folk activities, in particular in Madagascar. But it is also duplicated in other regions of the world. Today, we are going to talk about the early warning system adapted for fisher folk community, especially the small-scale fisher folk living from fishing activities in Madagascar. Next slide, please. Thank you. We are going to talk about the fishing context in Madagascar. So without delaying on the figure, 150,000 fisher folk lives from fisheries, 1 million living indirectly from fishing, and 69% of these fishery activities are still done with paddle. 1% only use motors. The most highlighted phenomena in this presentation will be wind, but there is a direct link between the wind and the wave. So this is one of the limiting factors of sea trip for fisher folk, because when there is a strong wind or a severe wave, it is causing 99% of sea accident for a small-scale fisher folk. So it has an impact on the well-being and activities of fisheries in general. Next slide, please. So we are going to talk briefly about sea accidents in general. What is causing sea accidents among fisher folk? Sudden change and unpredictable change of force and direction of wind, and these 5 or 10 last years, strong winds are more and more frequent. So these two factors are those who that cause accidents and loss in human lives. Early in the morning, even at night, there is a sudden change of wind throughout the day, or in an hour that is not expected by the fisher folk during when they go out at the sea. The weather is good, and when they are at the sea, there is a sudden change of the direction of the wind. It is causing a sea accident, as I said earlier, because there is still a high majority of fishing communities using paddle, using a small boat, so they don't have time to get to the seaside before this sudden change of the wind. So it has become more and more frequent these last years. If you are taking some examples, for example, in the south, in Lavanunu, the deep south of Madagascar, in 2005, there was this sudden change of the force and the direction of wind. In 2005, there were 31 fisher folk who lost their lives. They are all head of families, head of households. In 2010, there were 19 fisher folk who lost their life. lives due to this unpredictable change of force of wind. And in Fort-Dauphin, in the southeast of Madagascar, in 2013, we have noticed that accidents doesn't mean 3 or 5 accidents, but it could be 3 people in one boat. It has triggered the initiative to set up a meteor forecast. So for that, due to these figures, how to say, I have lived with these fisher folks community, and I asked myself, what can I do for them? Because I am so lucky to have access to internet websites on the weather forecast, but how to convey, how to disseminate this for fisher folk and avoid to the maximum accidents. Next, please. Next, please. Thank you. So, as I explained earlier, in 2009, we started to reflect, to experiment subsequent to the consultation of a reliable weather forecast. In 2009 and 2012, I have done much field work to consult fisheries community, consult specialists of weather information, traditional weather specialists, in order to ask them about the tools or the means in order to get the weather forecast. There is radio. Everyone has access to the radio, and in general, there is a delay between the information broadcasted on the radio and the use of this information. So in 2013, we have started to try and test, validate the system. And in 2014, we have started to set up the first meteor forecast panel in one of the villages of Fort-Dauphin region. And the same year, we have multiplied by 3, by 4, the number of panels that we set up. It has gradually increased. Next slide, please. How does it work? It is a simple system. As we have said earlier, the panel in the previous presentation table, it is based on panel and the information processing. Currently, we are using 2 websites that is deemed reliable. We are using we also are using Predict Wind offshore, Predict Wind Blue, which is a leader site regarding forecast in the world. It is using several weather models that are the most performing. We collect the information on the internet data that we consult on charged website. We don't use free of charge website, but those who offer the maximum reliable information. And there is a dissemination center there is a meteor forecast dissemination center, which is recording, processing all information and interpret this information through coded SMS. and the received information from the website is translated by color code with an interpreting via using a Beaufort scale, and subsequent to that, we are converting it to a coded SMS that we send by SMS to focal points. We have set up installation by site in a site where we put meter forecast panels. So we have 2-3 focal points per panel. Of course, there is the main focal point, but there are two assistant focal points, and the focal point display the information on the panel spreaded over 4 days. So small fisher folk can get weather forecast for the 4 successive days through the focal point, installing and interpreting the coded SMS from the dissemination center of aquatic service. So that is the flow. It is a simple flow. We take the weather data, which is mixed for information. We interpret and in the access to internet and connectivity between systems like talkie-walkie, mobile phone, where we have way forecast provides weather information, marine weather forecast for over 4 days, and from the dissemination center, because we have the contact details of each focal point in each village, we send a warning in case there is a sudden change. So for example, we have put the weather information for 4 days. As we saw on the panel earlier, we have the information on the morning. So if there is a sudden change of the wind or the speed or any parameters displayed on the panel, we have a warning triggering procedure. We have put in place this procedure in each village. We have set up a warning committee and also a communication system such as a megaphone to trigger a warning so that everyone instantly can take a decision to stop trip at the sea or to ask the fisher folk to come back, because in general there is 3 to 6 hours of a change of the wind direction. As I explained earlier, land, sea communication. We have also training and capacity building for focal points. We provide training to focal points who are the antenna for direct liaison with the village. So it's not only to receive the information, to interpret them, but they are our interlocutors in each village to communicate also information on what is happening on fisheries activities in general. We put in place as well particular vigilance as I said earlier, the warning triggering procedure. Now we are in cyclone season in Madagascar. We have also data archiving and analysis. We are going to present you later the data analysis over 10 years, what happened during this period. At a medium term, we are going to set up a seasonal forecast, especially for operators in fisheries, namely fish collectors and tourism operators. So that everyone could have the forecast according to the database that we have. For example, this 2023, we can already provide the forecast, the data, like what are the the most suitable month for fishing, and what are the suitable months for fish collectors. So all of this, as I said earlier, META forecast is currently becoming a tool to manage small-scale fisheries, because it can give several parameters. The forecast, it is its main role, the weather forecast, but it is also necessary even for the management of the income of the wives of fishermen. So it has a cross-cutting role. Next slide, please. So currently we have more than 40,000 fisher folk who have already benefited directly from META forecast, and around 50,000 to 75,000 indirect beneficiaries this year. This year, as Lilia explained earlier, we have a collaboration with the WWF in the West region and north of Madagascar. So META forecast currently contribute to support and support by giving basic forecast information, weather for information for fisheries community. So, next, please. As I said earlier, we have also set up a land-sea communication system. So there is a communication with the focal point, and the warning triggering committee in the village has been equipped with a phone for some fisher folk group. We couldn't provide mobile phone per fisher folk per boat, so they are grouping themselves. So there are two mobile phones at least for security, and there are two or three boats that are equipped with mobile phones, so that we can trigger the warning 3 or 6 hours before a phenomenon is hitting, and vice versa. From the sea, they can ask for weather information if there is some abnormal things when they are at the sea, and also for we can contact a few hours in advance for marketing, telling we have such amount of fish products. So because there is no storage in the area, so the system that we set in place contribute also to the to this marketing of the fishing products. Next, please. So now we are going to talk about some figures that we have taken for the 4 areas in Madagascar. We have the north, the eastern area, the west, and the southern part of Madagascar. We have taken 10 years data, 2012 to 2021 for each area, and we have noted that, for example, for the north region in 2012, there were 16 out of 30 days that are suitable for fishing, where sea trips can be done during these days. And in 2021, they only had 9 days. So the 21 days are days that are not suitable. When we are talking about non-suitable days, it is about over 20 kilometers wind, which is higher than what the fisher folk have the habit to. So during these 10 years, we have lost 7 days of sea trips. So it is equal to 84 days of loss. So if we so over out of 365 days, if we take the case of the north of Madagascar, throughout the year, they can do fishing only 30% during the year. So they are losing 252 days. So there is a necessity to find an alternative. So the lessons drawn from this is how to optimize the fisheries activities, because if we have this meteorological weather forecast, thanks to meteor forecast, the days where the little days where they can do sea trips, they have to maximize their activities during these days. And in capture, in the coast, in order to bridge this gap. But as I have explained earlier, we have said that strong wind is the cause, because when the wind is strong, fisher folk panicked to come back to the land. So before they didn't, it's not. So in the fishing areas that are over exploited, or there are some fishing areas where they feel secured, now they have access to meteor forecast, and they can have more reliable information, and they can go farther at the sea. They can feel secure and increase this capacity to catch more. So if we are taking the case for the other region with the same explanation, that there is a difference between the east and the south, especially in the north part and southeast, where we find the strong impact of this wind these last 10 years in Madagascar. Next slide, please. So here we have taken anti-cyclone and the low pressure of the equatorial part. The more the gap is big, the more the trade wind is how to say that, is severe. And we note that it explains the table that we saw earlier in the northern area of Madagascar. There is a high wind intensity, namely the monsoon wind, and in the southeast part of Madagascar, we have also this phenomenon since several years, which has an impact activities on the coast, not only for the fisheries, but livelihoods, activities for the community, and also around the Indian Ocean basin, which is impacted by this phenomenon, which for some time now, we have noticed that during the austral summer, meaning from November to April, the wind is becoming more quiet, and from May to October there is a strong wind. But for the southern part of Madagascar, it was not the case because it is due to the climate change. It is to explain to you that the strong wind phenomenon has a real impact on the development, on the livelihoods, activities for fisher folk communities. Next slide, please. As I explained earlier, what are the use of meteor forecasts? The benefits of meteor forecast, its assets. It can also be used as planning of fishing, as I explained earlier, for fishing, for collection of fish products. So fisher folk know beforehand, so they can plan a more productive activities. It is also used for financial planning and management for households. For example, here in the south, in the southern part of Madagascar, in general, it is the women who sell the products of their husbands. So women, they are also involved in the knowledge, in obtaining the weather forecast, because when they look at the following days, when they see that there is a red color code, for example, they manage their income based on the weather situation. It can also be an orientation of tools for fisher folk to the right fishing areas. And now we collaborate with local universities, the University of Toliara, and there is a branch of this university based in Fort-Dauphin in order to involve students to activities related to fishing and weather information. As I said earlier, it can also be a seasonal planning of collection of fisheries products for order and stock management, and its main role is to ensure the security of fisher folk community in general, to avoid accident at sea. As I said at the outset of the presentation, sea accidents have significantly decreased, and fisher folk community in the region where we set up this system are very much involved and comply with the information displayed on the meteor forecast panel. Next slide, please. What are the benefits for of meteor forecast acquisition? It doesn't require much scientific and complex information. The basis is the knowledge of the wind and speed, speed and direction. This is translated by Beaufort scale and the color code that meter forecast set up. It can be installed and used in all coastal areas of Madagascar and all over the world, as long as we have the GPS coordinates of each zone. We can have all information, especially the wind information, the wind direction, and the height of the wave. It is easy to understand and suitable for people, even for people with very low level of education, because in the area where we set up meter forecast, even children in primary school are involved. There is a school in Manungu in collaboration with the UNDP, a partner who involved meter forecast information in their class, in their school subject. It is also practical, sustainable, and less expensive compared to other devices which require satellite information requiring energy. So it is less expensive compared to these systems. It is it can also be installed the closest possible to the fisher folk community. It doesn't require electrical energy, and since 2015, in the areas where we set up this device, fatal deadly accidents have reduced. In some areas, there is zero accidents since 2015. However, before that, there were more accidents in the fisher folk communities. Next slide, please. So we have taken some examples in other regions in the world. We have taken 3 regions in Central America, in Namibia, and in South Asia. So if we look at the color code first, which considers wind, the height of wave, I assume that everyone knows in general Beaufort scale, which is used by the users of sea in general. For meter forecast, we use 4 color codes in the panels. We have the green code. Wind is quiet. It is the most suitable time to go at the sea. We have also the yellow color code. The speed, wind speed is 6 km per hour to 19 km per hour. The wave height is 0.2 meter. We have the orange color code with the wind speed of 20 to 28 km per hour. And the height of the wave is to 1 to 150, and the red color code for wind blowing at 29 km per hour and more. And the height of the wave is over 2 meters. So if we take the example, thanks to the weather model that the archive of Wind GoPro, which has data for over 10 or even 20 years in some areas. So if we look at the data for 2021 for these 3 regions of the world, we note that in Central America, wind was clement from January to December. They have yellow and green color code for over 20 to 25 days per month. In the in the southern part of Africa, we have suitable days for fishing, that is around 10 days plus. And for the rest, in the Asia, we note we find suitable days around January, February, and September, October. All of these are data available to Wind Go Pro, and in archives we are using also on our site, because as I said earlier, they are using worldwide acknowledged weather forecast and the most reliable. And at the same time, we are using information from Predict Wind, which is the world leader for wind forecast worldwide. So it is an insight that's showing that all over the world there are some parts that are impacted by severe winds, and some that still have the chance to have some additional more additional days. This is just for everyone to understand what are the information that we are taking into account in the META forecast. So our perspectives and for the sustainability of the panel is a continued improvement. Even we have developed and improved the dissemination capacity of information. We have more and more panels to get installed in order to disseminate information. One of the challenge is started from Madagascar to cover all coastal areas of Madagascar to the minimum 2,000 panels. In particular, we are going to prioritize areas where there is strong wind and areas that are subject to strong winds, especially to start with. We always need collaboration and partnership, because it is an investment. It requires costs for the installation and logistics. Also, the establishment of an empowerment system, because early warning system will not always depend on the partners. There could be panels, but in order to operate it, to make it running, they can put in place an empowerment system, thanks to the setting up of activities of business model, because in order to run META forecast, we need costs around 35 USD per panel. So we have calculated that it is 250 official folks per village using the panel. So each community of official folk contribute up to 40 cents USD per month, which is small compared to their activities. And now we are discussing with communities, with stakeholders, how to set up this empowerment system for the sustainability, because there is a research component, dissemination improvement component, the panel maintenance and the replacement of the panels, which last 3 to 5 months, years to the maximum. So all of this requires some costs, which is not a lot compared to the impact and the use of this mechanism. The creation of a workshop for the local production of inputs So each village could group themselves and manufacture the panels by themselves and maintain them by themselves. We have also a training of trainers of technicians in meteor forecast and initiation of young people on marine weather. As I said earlier, at schools, children are started to be educated on marine weather because given the climate change, we cannot avoid this the phenomenon of severity of wind. So we need to adapt ourselves. So small, starting from young age, children should be involved and also to have access to information. As I said earlier, also put in place adaptation measures related to strong winds and climate change. We are also open. We started to collaborate with the experts and weather specialists at the national and international levels so that the information will be the most reliable possible and the most useful possible to the community of fisher folk. Next slide, please. So before closing my presentation, I would like to thank the partners who trusted Meteor Forecast and Aquatic Service for the technical support and the installation of these panels. I'm not going to mention them one by one, but I would like to thank everyone for trusting Meteor Forecast, which has changed the life of fisher folk communities, because there was a village like what we saw in Lavanunu, all head of families, all men in a village, 31 men in a village, in 50 households. More than half of these men lost their lives because they didn't have the weather forecast information. And imagine the impact of that at social level, at cultural level, at economic level of the village. They take much time to recover their economy. They have to wait for a younger generation to start the sea trip. So thank you very much to everyone who contributed to the setting up of Meteor Forecast, because your contribution could save lives and improve the living conditions of these communities who are more and more vulnerable to strong wind phenomenon in Madagascar and also in other regions over the world. Next slide, please. This is to share some useful links in order to get some documents. You could. We have some downloadable videos on YouTube. Some are in French, translated in Malagasy, which are explaining the impact and the involvement of wives of fishermen, young people and women are also among the main actors in the development of Meteor Forecast, and they deserve to get the maximum of information to support their husbands and also to adapt to these phenomena. I have reached the end of my presentation. The next slide is acknowledgement. Thank you very much, very much. I hope that it was clear. Although I took some more time, I am available if you have some questions or remarks regarding the presentation. Thank you very much, Mr. Tatump.
Thank you, Mr. Toke. That was wonderful. So informative and so inspiring. My name is Anita Van Breda, and I'm with the DODEF team here in Washington, D.C. We do want to be respectful of everyone's time, and we will end on time. But you may please put your questions or comments in the chat. If we don't get to them today, we'll try to follow up in writing to get you the answers to your questions. So feel free to add any comments or questions in the chat, and we will catch up. But I also want to, before we do have to leave, want to thank Luz and Lilia for organizing this session, and for Mr. Toke for generously donating your time today to this really important discussion. In the few minutes that we have left, I will try to ask some of the questions that have already come through in the chat, Mr. Toke. And the first question is, what is the product used to obtain wind and wave forecast? And what is its spatial and temporal resolution? Technical question from our colleagues in Colombia.
Je réponds directement, on regroupe les questions. Je réponds directement.
Can I answer straight away?
Yes, please.
We are using two models, two sites, websites. We use WindGuru, which have several models. Let's take the example of GFS. We are using also wind, which has a model for resolution. They have 8 kilometers to 1 kilometer of resolution. So these are recent websites. They started in 2017, but they are very well performant. As I said earlier, they are world leader regarding wind forecasting. I hope I answered to the question.
Thank you. And unfortunately, we are out of time, but I am going to give Mr. Abdul the last word quickly, please, before we have to sign off, and then we will get to everyone else's questions by writing. Thank you, Mr. Abdul.
All right, thank you very much. Thanks for the great presentation. I'm actually from the Comoros Islands, even though I'm housed in Texas. We have a big problem similar to this one, where a lot of fishermen get lost at sea. So I run an NGO in there, an environmental NGO, but also trying to help with this issue. But one problem that we have encountered is that the adoption of the fishermen of any of the solution that we provided. So my question is, how did you get the fishermen community to adopt the solution that you provide to them? One second question, you mentioned about using a GSM phones. How far, what is the range where your fishermen are allowed to go, to do the fishing? Because that's also one of the problem. Some of our fishermen can go up to 70 kilometers deep, in the ocean, and the GSM range doesn't get there. That's two questions that we have. So the adoption and the range to which a fishermen are able to get fishing. Thank you.
Merci.
Thank you. Regarding the adoption, that's the reason why we took the time from 2009 to 2012 in order to test in the villages, and we validated together with the fisher folk community. We have done an approach in order to get their we have done the test together. We presented this product in order to prove that it is an efficient thing. We took time. We took much time, at least 3 to 4 years, in order to get this trust of a fisher folk community. And we are trying to improve to the maximum the data weather that we are using. So we won their trust in each village. We have some fisher folk, so between who using the early warning system and between themselves, they have shared their experience. So it is from March 2 years, and it worked. And regarding the range of the phone, mobile phone, in general, they already have the information at the land with the panel, and in case of a sudden change of wind speed in Madagascar, mobile phone has further scope, further range. I would say more than 10 kilometers, but for some a small scale fisher folk, it is about 2 kilometers. But more of performing both, we use other information. That's the reason why I mentioned about the use of the VHF. Thank you.
So thank you, everyone. This has been a great presentation. I think we'll have to have another session with Mr. Toke and his colleagues based on the interest we see here. If you would like more information on the Environment and Disaster Management Program, please do contact us directly, and we will follow up with Mr. Toke and our colleagues in Madagascar to provide you all with written feedback to the questions that you put into the chat. But then at the close, I'd like to thank you all again for joining us, and we look forward to seeing you at the next continuing education seminar. And as Lou said, if you have requests or suggestions for topics you would like us to address, please do feel free to share them. Thank you, everyone, and have a great day.
Thanks all. Bye-bye.
Merci beaucoup.
Thank you.
Merci.
Bye.